Today we have to see about admission control. So admission control is something that decides the admission or rejection of request for the setup and reconfigure the radio barriers, which means the request should be admitted provides a quality of service requirement that can be met, and that the QoS requirements of already accepted connections are not affected by new request acceptance. And also the admission control is something that WCDMA because there is no hard limit on maximum capacity. And also admission control algorithm is executed separately for uplink and downlink because of different issue impact in communication direction. This is the communication between the upper link, how the noise and the new user is blocked about this point. Okay, and next is this WCDMA, that is carries and code sense multiple access, supports multimedia services, and so the admission control algorithm must take into consideration that the amount of radio resources needed for each connection request will vary, and similarly the quality of service requirement in terms of real-time and non-real-time transaction should also be considered in an effective admission control algorithm. And meanwhile, in addition to this connection setup request, the admission control may also be triggered a handover procedure. That is a basic procedure, and a transport channel type switching is occurred. And let us go. How does admission control take place? So the transaction setup request UMTS is always triggered for UE side, that is user equipment side, either because of user equipment itself that is initiating an interaction with the network, or because of user equipment is answering a paging message. The user equipment is nothing but our mobile devices. So here, prior to the transaction setup procedure, the signal path from the UE towards a CN needs to be established, which in the case of UTRAN is accomplished by means of RRC connections and also radio access network application protocol, which takes place in interactions. With the help of RRC and NAP protocol, the transmission request reaches the CN. So this is a diagram that represents a messaging protocol in which involved the control access. So therefore, it is always a CN that triggers an RAB establishment by means of RAB assignment. That is, the message is sent from the CN to SNRC. With the arrival of such a message, the admission control algorithm is executed. In if the connection can be admitted and SRNC established the resource, that is the radio resources, and it interfaces by means of RRC radio barrier. And let us see the power control of WCDMA. So the transmitter adapts the output power according to the path laws, mainly to solve a near problem. And its main goal is that all the users should experience the same SIR. Next is your open loop power control, which means not signaling. That is, the user equipment uses preamble RACH for access of node B. And let us see about the power control implementation of the network. Next is your closed loop power control of WCDMA. That is the inner loop power control, that is also called as a fast power control, which controls take place between a user equipment and node B and the transmitter power in order to reach the receiver with a required target. And outer loop power control is also said to be a slow power control, and it take place between the node C and RNC. This will be clearly seen in the diagram. And next is your congestion control. Congestion control faces a situation in which the quality of services guarantees at a risk due to the evolution of system dynamics, mobility aspects, and increase in interference and traffic variability. And congestion situation in the radio receiver can be caused by excessive interference. Thus, the congestion algorithm need to monitor the network status continuously in order to correct the overload situation which is present over there. And moreover, the congestion control algorithm needs to exhibit a faster reactivity under the overload condition in order to prevent the degradable of quality of connection. And next is your congestion control and load control. So here in this diagram you can clearly see that the congestion control is closely supported by admission control and handover, where RT load is something that real-time load and NRT is something that near non-real-time mode. And the congestion of the load control algorithm will resides in network side, and it will be based on the measurement of acting and algorithm input. And whereas the congestion situation is triggered, the congestion resolution acts as a aid of RRC protocol. Next is your code management. Code management is devoted for managing the downlink of orthogonal variable spreading factor code tree used to allocate a physical channel orthogonally among the different users. The main advantages of this codes is downlink is perfectly orthogonal, and the drawback is that it is limited number of available codes. Therefore, it is important to allocate or reallocate the channel codes in the downlink in the effective method, that is in order to prevent code blocking. Next is your code blocking, which means it indicates a situation where new call could be accepted based on the interference and also based on the spare capacity. And due to the inefficient code assignment, this sparely capacity is not available for new call, which means it is blocked. So this diagram is an example of code allocation, which preventing the code blocking. Next is handover in WCDMA. So in WCDMA, more responsibilities are open as long as the mobile terminals are connected to more than one cell simultaneously due to the presence of rec receivers, that is between the user equipment and node B. So handover involves in three different ways, that is one is for measurements, and next one is your decision, and third one is your execution. So measurement may be of different categories, maybe intra frequency, that is on a same UTRAN carrier, or interfrequency on different UTRAN carrier, or interact, that is between the radio access technology and another UTRN. And next is types of handover in CDMA. So we have four types of handover. The one is your inter radio access technology handover, so which means handover from WCDMA to GSM, and the traffic and control channels are disconnected and may be reconnected. And interfrequency handover is something that user equipments must change the CDMA carrier frequency during the handover. So here the traffic and control channels are disconnected and it also must be reconnected. Next is your software handover. So during this handover, the user equipments has a concurrent traffic, which means the connection with 2 or 3 or 4 RBS. Next is your handover should be very less negotiable. And next one is your software handover. Software handover. Software handover is something that it's between two cells of the same site. So this handover is very simplified with timing sector, and it can easily identify the timings. So this is a handover process in CDMA. So in this first diagram, it represents the monitoring the neighbor cell pilots, and second is adding destination of RBS, and third one is your dropping the original of RBS. So this is the block diagram how the soft handover and changing active set in CDMA. So next let us go to the cell breathing. So cell breathing is something that the user increases the maximum allowed path losses for a reference user decreases. So in such cases the result is that the reference user path losses is higher than the maximum tolerable limit. So here it can be seen that the performance achieved depends upon the cell load level. On the air interface, the interference level, this phenomena is said to be your cell breathing because of your variable cell coverage. So the main conclusion about this topic is that various radio resource management function which can discussed helps into maintain the desired quality of services for user satisfaction. Next is your radio resources and QoS management are a very important framework in WCDMA system because the system relies on them to guarantee certain target of QoS and maintain the planned coverage area and offer a high quality. So the last one is that the multimedia capabilities, newer technology for LTE and 4G are advancing day by day. So the radio resource management keep playing an important role in optimizing the traffic. So these are the reference you can refer, and if you have any clarification related to this topic, feel free to contact. Thank you guys.